All right, so we're looking at quadratic features today. Those features include the y-intercept, the x-intercepts, the line of symmetry, the vertex, the domain, and the range. Okay, so we're looking at these given a graph, and first thing we'll notice is we're looking for the y-intercept. Let's color code some of these. So our y-intercept is the point when we get something for doing nothing, which is right here. How did I lose my brush? Let's fix that. Okay, so this one's our y-intercept. And a note about points is that we always write them as input, comma, output. And our x represents all of our inputs. So the x changes the inputs, this direction. And then our outputs change as we go up and down. Okay, so this would be our output. So our y-intercept that we're claiming will be at I do nothing, so 0 goes first because that's what we do, and then I get a 5. So we can see that point being brought up on our Desmos over here. Okay, so next thing, we're going to look for our x-intercepts, and I see that this graph gives us 2. Okay, an x-intercept is what we do to get nothing. And so we have one at 1 and the other at -5. So when I do 1, I get 0. And when I do a -5, it looks like I get 0. So these are my two x-intercepts. Okay, so our line of symmetry. Line of symmetry is the line that cuts the graph in half. It's always in the middle of my repeated values. So I've already started using red for my repeated values, so I'm going to point some more of them out. There's a 5 there and a 5 there. Right? There's an 8 here and an 8 here. In the middle of those is right here. It's always going to be a line that goes up and down. Okay, and that's called our line of symmetry. Notice how the distance over here is 3 and the distance this side is 3. This is 2 and this is 2. This is 1 and that's 1. So it's a mirror on both sides. It's a mirror image. So let's write that out. Since it's a line where x is always the same, we're going to write x equals -2. And then let's make that color appropriate so it matches what we're doing so far. Okay, so we have this shape that's kind of forming here. We have our x-intercepts. One's at -5. One's at 1. And then our y-intercept, which is at 0, 5. Okay, trying to make those a little bit clearer on the video. Okay, so now we kind of see how it's forming. If you wanted to, you can kind of freehand on this side over here. It kind of goes up and then over and then back down. You can kind of tell how it's kind of forming. The next thing we're going to point out is the vertex. The vertex is where it changes direction. So I want to explain this definition really quick. So we can tell the vertex because on this side we're going up, and on this side over here we're going down. And so there's a change in direction right in the middle here. And we call that the vertex. Okay, I missed something earlier. This is an x-intercept, and this is also an x-intercept. So I'm going to make sure I label those. Okay. And so that's our vertex at the very top in this case. Lots of people consider the vertex the maximum or the minimum. Okay, and because it is a change in direction, it ends up being either the maximum or minimum, but it's a consequence of the definition of the word vertex. Okay, a vertex is where it changes direction, and that tends to be where we're at a relative maximum or minimum. Okay, so let's identify that. It looks like my vertex would be at, I did -2. That's my input, excuse me. My input is -2, and my output looks like it's 9. Okay. Desmo somehow knows that that's the color that I wanted. That's great. Okay, now we definitely see it forming here. We've included the vertex, the line of symmetry, the x-intercepts, and the y-intercept. Let's talk about the domain. So domain is everything you can possibly do. Okay, so this is definitely confusing, but these arrows point down, but they also have a component, a very small component. Let me make that smaller. Of left direction, and this one points down and then has a small component of right direction. So it's going to keep going in both of those directions forever. A hint just for linear, exponential, and quadratics, most functions that we deal with in high school have the domain of all real numbers. Okay, and our range. Our range is what we can possibly get. So we notice that this graph over here has a maximum of 9. So what we can get is the y values, and because it's less than that, I'm going to say everything has to be less than or equal to 9. And notice how it just shaded in everything that's possible as an output. Okay, this is everything that's possible to get. I can get any number of an output going up and down, and then my inputs could actually be anything side to side. There's no limit to what I can do as an input. Okay, but it's not relating my inputs to my outputs when we do that. Okay, so next part, we're going to use our x-intercepts to write an equation. Okay, so we know that when we do a 1, for instance, we're supposed to get 0. So we write an equation that forces that to happen. So if I have an x that's 1, I would subtract 1 to get 0. Notice how it goes through our x-intercept right here, which is perfect. Okay. If I do the same thing for the other point, assuming that my x is -5, if I have a -5, what do I do to get 0? I'm going to add 5 to that. Notice it goes through the other point. I'm going to change the color to red so we're consistent here. It's my equation based off of the x-intercepts. And I don't want lines. I want to make a quadratic parabola, so I got to multiply these things together, and my length and my width together, make that quadratic. Okay, so notice now we have a parabola, but it's going the wrong way. So how do we fix that? I notice that we have everything the opposite. So instead of a -9, we're supposed to have a +9. So I put that negative in front. Okay, that signifies that it's opening down. Notice that's all we needed to add, and everything just flips, and it fits within that range now. Okay, so continuing on. Based off of this, we can write our standard form. I'm going to work out the process for that over here. So I like to show the box method. You might want to use FOIL, but one of the dimensions goes on top and the other dimension goes on the side. And we're just multiplying to get the inside of this, and that inside is considered the standard form. So multiply x by x to get x squared. -1 times x is -1x. 5 times x is 5x. And then -1 times 5 is -5. I take these things and I add them up. I have 1x squared. I have 5x's minus 1x, which gives us 4x's. And then I have the -5. Okay, the thing we cannot forget is the negative that we had in the very front. So all of this needs to be negative. We need to take the opposite of all of this. So we end up with -x squared minus 4x plus 5. Okay, that's because this one would be the graph of it opening up, and then this one makes it go down. Okay, without that negative, it's not facing down. Okay, and so let's write that out over here. So negative x squared minus 4x plus 5. Notice that it lines up in the same exact spot as the other ones. Okay, so it lines up in the same exact spot. What would happen if I didn't change all the values and I just left the front negative? It would be in a completely different spot. Okay, so we have to change every value from a positive to a negative and from a negative to a positive for it to line up like we want it to. Okay, so that would give us our standard form. Lastly, this one's a lot easier. We're going to use the vertex form. Okay, remember vertex form is, we still have the a term in front, x minus h squared plus k. Okay, so I'm going to walk us through how we do that without using the formula. Like, how do we come up with that formula? So first of all, we're trying to find a graph that would go through this point. Okay, so we're going to write an equation that when I plug in a -2, we get 0. Okay, that's what our axis of symmetry tells us. And just like the x-intercepts, we're looking at the x value and we're trying to make 0. So if I plugged in a -2, I need to add 2 to make that equal to 0. Notice how it goes straight through that point like we want it to. But I don't want a line that goes through that. I want a quadratic that goes through that. And I want it to go the other way. I don't want it to look open up. I want it to open down. So that's how we fix that. Now I have to move this whole graph up to where the other vertex was. So I need to add 9 to it, and I end up in that space. Okay.